Hello students, welcome back. I hope you sang right. Okay? I hope you hung in there for Cramer's rule. So in this video we shall solve this linear system, a 3x3 linear system using the method of determinants, or what we call Cramer's rule. Please, it is highly recommended that you do part 1. Part 1 we did it with on a 2x2 linear systems. So this part 2 is on 3x3 linear systems. Okay, so we are going to kind of use the same method. We are going to use the same steps we used in a matrix inverse method. You know, we want to make sure that if you can simplify it, you simplify it. Then you make sure that the variables are complete, make sure that the variables are aligned and that the constants are aligned as well, and then you can use the Cramer's rule. Okay? I wish I had a Samdom's rule or Chukwuemeka's rule, you know. Don't worry, I'm kind of working on it so that I will have my own rule. You know, we are learning people's stuff, so I need somebody to learn my stuff as well. So I challenge you to produce your rule. How about it? You know, I challenge you. You're learning mathematics. What other people have come up with. Why don't you come up with yours so that people will learn yours as well? That's a challenge I have for you. Now, we are going to go over the main idea of Cramer's rule, but let's look at the steps first. For question 1, we have 2x plus 4y minus 3z equal to negative 18. Y is equal to z minus 3x minus 5. Then x minus 2y plus 4z is 14. So we follow the same steps we did in matrix inverse method. We just don't use the formula for the matrix inverse method. We just don't use it. But we follow the same steps that we pointed out in the video on matrix inverse method. First of all, make sure that can you simplify it? 2, 4, negative 3, negative 18? No, you cannot. 1, 1, negative 3, negative 5? No. 1, negative 2, 4, 14? No. Then make sure the variables are complete. If you look at the 3 equations, the variables are complete. But are they aligned? They have to be aligned. Okay? Are the variables aligned? If you look at it, equation 2 is not aligned. So we have to align it. So this is 2x plus 4y minus 3z is negative 18. This will be 3x plus y minus z is minus 5. And this is x minus 2y plus 4z is 14. So once they are aligned, okay, once they are aligned, this is what you do. And honestly, I like this method because it is the easiest method. I mean, it is easier than matrix inverse method. It is easier than row reduction method. Okay? So once you have this, this is the way you write it. You write the matrix. Write the matrix of coefficients. We have 2, 3, 1, 4, 1, negative 2, negative 3, negative 1, 4. Then write the matrix of the variables x, y, z equal to this times this. Okay, we are having to put these 3x3 linear systems into matrix form. That is the way you do Cramer's rule. When you have checked out the steps, then you write the linear system into matrix form. Matrix of the coefficients times matrix of the variables will give you the matrix of the constants. -18, -5, 14. So now, once you have written this, then Cramer's rule states that x is equal to determinant. You know it's method of determinant. You replace the coefficient of x, 2, 3, 1. Are you with me? You replace the coefficient of x, 2, 3, 1, with the matrix, with the constants. The column of the coefficient of x. You replace that column with the column of constants. So this is a -18, -5, 14. And then you write the rest. 4, 1, -2, -3, -1, 4. All over, determinant of this, all over, determinant of the matrix of coefficient. 2, 3, 1, 4, 1, -2, -3, -1, 4. So this is the way you do it. That is the way you find x. If you want to find y, this will be determinant. You write the x, 2, 3, 1, then you replace the column of the coefficients of y with the column of the constants. -18, -5, 14, then -3, -1, 4, all over determinant 2, 3, 1, 4, 1, -2, -3, -1, 4. That is your y. Now, can you write z for me? Can you write z for me? What is z going to be? What will it be? This will be determinant. You write the x, 2, 3, 1, 4, 1, -2. Then you replace the column of z, the column of the coefficients of z. You replace the column of the coefficients of z with the column of the constants. So this will be -18, -5, 14. All over 2, 3, 1, 4, 1, -2, -3, -1, 4. So you see that they have the same denominator. That they have the same denominator. So can we, if we want to find this x, y, z, can we just go ahead and find the denominators first? Can we do that? Saves us time. Can we kind of find the denominators first? So if we find the denominators, the denominator, the determinant of the denominator. So that means you have to view the videos on the determinants. Determinants of 2 by 2 and determinants of 3 by 3 matrices. You still remember the determinant, how we can do it? Plus, minus, plus, minus, plus, minus, plus, minus, plus. So you can save us time, saves us time if we do it this way. So if we do that, what row should you think I should pick? What row should I pick? I think I can pick row 2 since it has the most simple numbers. Row 2. So I pick row 2. So this is -3 determinant. 4, -2, -3, 4. Then plus 1 determinant. That will be 2, -3, 1, 4. Then minus 1. Minus 1 determinant. can put this here. Minus minus 1 determinant. Bam, 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 bam. I'm finding that of the denominator. Bam, bam. 2, 4, 1, negative 2. So this will be what now? Minus 3, right? 4 times 4 is what? 16. 16 minus what? 6. Then plus 1. 2 times 4 is 8. 8 plus 3. 8 minus 3, which is 8 plus 3. So this is 16 minus 6, yeah. Then plus 1, 8 plus 3. Then plus 1, minus 1 is plus 1. This is minus 4, minus 4. So this will be what? Minus 3 times 10. 16 minus 6 is 10. Plus 11. Minus 1 is gone. Then minus 8. So that is minus 30 plus 11 minus 8. What is the determinant, folks? Minus 30 plus 11 is what? Minus 19, right? Minus 10 minus 1 is 9. 2 minus 1, 1. Minus 19. Minus 19 minus 8 is minus 27. Minus 27. So the denominator is just minus 27. So I can come here and I just write over negative 27 over minus 27 over minus 27 over minus 27. That's the nice thing about Cramer's rule. See? Nice thing about it. Okay. Let us go ahead and, let's find x. Let's go ahead and find x. So the determinant for the x, what do I use? I can also use row 2 because row 2 is the easiest one for me. It's the one that has the most smallest numbers. So that is a minus 5 determinant. Bam, bam, bam. 4 minus 2 minus 3, 4. Then plus 1 determinant. Bam, bam, bam. Minus 18. 14. Then minus 3, 4. Then minus 1. Minus 1 determinant. Bam, bam. That is minus 18, 4. 14 minus 2. Okay, folks, what do we have here? We now have that this is 5 times 4 times 4 is 16 minus 6, right? Then plus 1 times negative 4 times 8 is 32, 2, 3, 4 times 1, 4 plus 3, 7. Negative 72 plus 42 because minus 42 plus 42. Then minus 1 is plus 1 determinant times. This is 36 minus 56. So this will be 5 times 10 plus 1. Minus 72 plus 42 is what? Plus 1 times minus 30 plus 1 times minus 20. So what do we have here? So this is 50 minus 30 minus 20, which is 0. 0. See that? So this is 0. So we can come here and we say that this is what? 0 over 27. Okay? And that gives you what? 0. So x is 0. X is 0. And that was what we got. in the matrix inverse method. But we are still going to check it anyway. We shall still check it. It's always good to do what? Check your work. Now let's look at y. For y, what row should I use now for y? Kind of want to use row 2 too. Row 2, 3, 5, 1. Okay, let me use row 2. So this will be minus 3. It's like I'm always using row 2. I can use row 2 or row 3, it doesn't matter. Okay, but it's like row 2 is easier for me because it has the smallest numbers. So this is minus 3 determinant, minus 18 minus 3, 14, 4, then plus minus 5 determinant, 2 minus 3, 1, 4, then minus 1 determinant, let me check this again, 2 minus 3, 1, 4, then minus 1 determinant, 2 minus 18, 1, 14. So this will be minus 3, this is a minus 72, plus 42, then minus 5, this is 8 plus 3, okay, right, 8 plus 3, then plus 1, this is 28 plus 18, 28 plus 18, so this is minus 3 times minus 30, okay, minus 5 times 11, plus 1 times 8 plus 8 is 16, 46. 46. So this will be 90 minus 55 plus 46. 90 minus 55 is what? 35, right? 90 minus 55, 35 plus 46, 81. So this is 81. 81. Okay, 81. Now our y will be 81 over negative 27, which is negative 3. Our y is negative 3. So the next one is to find out what? Z, that's in zebra. Next one is to find out z. So our z, I still want to use row 2. I still want to use row 2. Okay, if I use row 2, this will give me negative 3 determinant. But that doesn't mean you can't use row 1 or row 3. You can, and you will still get the same thing that I got if you do it properly. We have 4, negative 18, negative 2, 14, then plus 1, I have 2, 1, negative 18, 14, then minus 5, determinant 2, 4, 1, negative 2. Okay, so folks, what is this now? This is negative 3. This is 56 minus 36, right? Plus 1, 28 plus 18. 28 plus 18 plus 5, negative 4 minus 4. So this will be negative 3 times 20 plus 1 times 46 plus 5 times negative 8. And that will give us what? Negative 60 plus 46 minus 40. Negative 60 plus 46 is negative 60 plus 46. Okay, this is for negative 14. Negative 14, don't mind. Negative 60 plus 46 is negative 14. Minus 40 is negative 54. So we have negative 54. Negative 54. Okay? So our z will be negative 54 over negative 27, and our z will be 2. Do we stop here? No, of course. We have to do what? Check our work. So let's go ahead and check this. When we check with the main equation. When we check, we have to check with the main equation. We will check it to make sure that it satisfies of each of the equations, each of the 3 equations. So we start with the first one. 2x plus 4y minus 3z is negative 18. So let's kind of say something here. You want to make sure that the first thing you do is to find the denominator. In Cramer's rule, all the variables, that's when you find it, when you write it, they all have the same denominators. So you find the determinant of that denominator, which is the determinant of the coefficient matrix. Okay, that's, you want to do it first. After following the steps, then when you write out what each of the variables will be, the first thing you want to do is to find the determinant of the coefficient matrix, which is the denominator. And after that, you can now find the numerators. Now this is left hand side, right hand side. Left hand side is negative 18, right hand side is negative 18. Left hand side 2x plus 4y minus 3z. So this is 2 times 0 plus 4 times negative 3 minus 3 times 2. So this is 0 minus 12 minus 6, which is minus 18. Minus 18 on your left, minus 18 on your right. You jump a little, You want to touch the sky, and just jump a little. Because you have just did only one. So we verify the rest. We check the rest, rest of the equations to see whether it works. Equation 2, y equal to z minus 3x minus 5. Left hand side, right hand side. Left hand side is y. Right hand side z minus 3x minus 5. So y is negative 3 and z here is 2 minus 3 times 0 minus 5. 2 minus 0 minus 5. 2 minus 5, negative 3. Negative 3 on your right, negative 3 on your left. Jump more than the first time you jumped. Just after the first time you jumped. Then, checking for equation 3, x minus 2y plus 4z is equal to 14. Left hand side, right hand side. Left hand side, x minus 2y plus 4z. Right hand side, 14. So x is 0. This is minus 2 times minus 3 plus 4 times 2. So this is 0 plus 6 plus 8, 14. 14 on your left, 14 on your right. That is silly. That is silly. Okay, let's go to question 2. Question 2. 3x minus 2y plus z is equal to 9. X plus y plus 4z is equal to 4. 2x plus 3z is equal to -1. So, can we simplify equation 1? 3, -2, 1, 9, no. Equation 2, 1, 1, 4, 4, no. Equation 3, 2, 3, -1, no, we cannot. Now let's check the variables and make sure that they are aligned. Equation 1, variables are complete, is aligned. Equation 2, variables are complete, it is aligned, they are aligned. But equation 3, something is missing in equation 3. What is missing? Equation 3, y is missing. We have to complete it. Remember, if any of the variables is missing, you have to complete it. So we now rewrite this as 3x minus 2y plus z is 9. X plus y plus 4z is 4. Then 2x. Now, since it is missing and we have to complete it, it will be plus 0y plus 3z equal to -1. Okay? Now, after writing this, the next step to do is to write the matrix of coefficients. We have 3, 1, 2. We have -2, 1, 0. We have 1, 4, 3. Times the matrix of the variables x, y, z equal to the matrix of the constants 9, 4, -1. Then we now write our Cramer's rule. So x will be determinant. We replace the column of the coefficients of x with the column of the constants. So this is 9, 4, -1, -2, 1, 0, 1, 4, 3, all over the determinant of the coefficient matrix. 3, 1, 2, -2, 1, 0, 1, 4, 3. Y will be determinant. Our x, 1, 3, 1, 2. Then we replace the column of the coefficients of y with the column of the constants. 9, 4, -1, 1, 4, 3. All over, it will have the same denominator. 3, 1, 2, -2, 1, 0, 1, 4, 3. Then z will be determinant. We write the column of the coefficients of x, 3, 1, 2. We write that of y, -2, 1, 0. Then we replace the column of the coefficients of z with the column of the constants. 9, 4, -1. All over determinant 3, 1, 2, -2, 1, 0, 1, 4, 3. Alright. So what is the first thing we do? Like I pointed out, let's find the denominator first, since they have the same denominator. Let's find the denominator. What row should I use? I want to use the row that has at least a 0. Okay, you can use row 2 because at least it has 1, 1, right? But let me not use row 2 this time. Since I used row 2 for question 1, let me use row 3 this time. At least it has a 0 here, so that, 0 times that times whatever will be 0. So plus minus plus. So I only deal with plus. Okay? So I have 2 determinant, bam, bam, negative 2, 1, 1, 4. Then minus 0 determinant, negative 2, 1, 4, minus 0 determinant, bam, bam, 3, 1, 1, 4. Although we are not interested in that 0. Then plus 3 determinant, bam, bam, 3, 1, negative 2, 1. 3, 1, negative 2, 1. So this will be 2 times, this is negative 8 minus 1. Then minus 0, we don't need anything there. Plus 3 times 3 plus 2. Right? 3 times 3 plus 2. Negative 8 minus 1. Alright, so what we got now? This is 2 times negative 9 plus 3 times 5. So which will be what? Negative 18 plus 15. Negative 18 plus 15. And that is what? Negative 3. So negative 3 is our denominator, which is the determinant of the matrix of coefficients, or the coefficient matrix. So this will be negative 3. This will be negative 3. This will be negative 3. Alright. Next thing we do now is what? Let's now solve for x, and solve for y, and solve for z. Okay. Let's solve for the numerator for x, numerator for y, and numerator for z. For x, we have what? So for x, let me use row, I'm going to use row 3 anyway, because row 3 is the easiest for me though. Row 3 is the easiest for me to use. Plus, okay, this is minus 1, determinant, bam, bam, negative 2, 1, 1, 4. I can really forget about the 0. I mean, I can just forget about the 0, so I wouldn't come and start spending time. So 0 can go, then plus 3, determinant, bam, bam, 9, 4, negative 2, 1. I can simply forget about the 0, man. Forget about it. So this will be negative 1, this is negative 8 minus 1, plus 3, this is 9 plus 8. That will be negative 1 times negative 9 plus 3 times 17. So this is 9 plus 51, which is what? 60. 60. 60. So x, so this is 60. 60. 60 over 3 is what? Negative 20. Have this for x. Now I go for y. For y will be, what row should I use for y? I'll just use row 3. Let me just use row 3. So plus here, 2 determinant, bam, bam, 9, 4, 1, 4. Then minus, 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 minus 1 determinant, bam, bam, 3, 1, 1, 4. then plus 3 determinant, bam, bam, 3, 1, 9, 4. Right? So this will be 2. 9 times 4 is what? 36. Right? Minus 4. Then minus 1 is plus 1. This is 12 minus 1. Plus 3 is 3 times 4 is 12 minus 9. So this gives me 2 times 32 plus 1 times 11 plus 3 times 3. 3 times 3. So what do I have? This is 64. 64 plus 11 plus 9. 64 plus 11 is what? 75. Right? 64 plus 11 is 75. 75 plus 9 is 84. 84. 84. So our y, the numerator, this is 84 over negative 3. 84. So our y will be negative what? 3 into 8 is 2, 6, 24 is 8. Negative 28. I can actually do my z here because of the 0 here. My z, what will my z be? Z, I will use root 3 because that's 0. Let me just use root 3. So this is plus 2. 2 determinant. Bam, bam. Negative 2, 1, 9, 4. Then plus minus 1 determinant. Bam, bam. 3, 1, negative 2, 1. Right? So that will be 2, negative 8 minus 9, minus 1, 3 plus 2. Right? Three plus 2. So this is 2 times negative 17 minus 1 times 1. Minus 1 times 5. Don't mind me. Okay? So this is what? Negative 34 minus 5. Minus 34 minus 5. Which is what? Minus 39. Minus 39. So z will be negative 39 over negative 3 is going to be what now? Negative 39 over negative 3 will give us what? 13. 13. Do we stop here? No way! We have to C-H-E-C-K. I've got to erase this so that I can check my work. I got to erase this so I can check my work. I will check, from equation 1. 3x minus 2y plus z is 9. Left hand side, right hand side. We always check with the main equation, not the modified equation. So this is 3x minus 2y plus z, and this is 9. So this is 3 times negative 20 minus 2 times negative 28 plus 13. Negative 60 plus 56 plus 13. Negative 4 plus 13. Negative 9. Negative 9 on your left. I'm sorry, negative 4 plus 13 is 9. So 9 on your left, 9 on your right. You eat some vegetables. Vegetables make you healthy and gives you vitamin C. You know what I also teach? You learn biology too. You're learning biology, Okay, let's check for the next one. Let me erase this. So we can check for the next one. And this, so we can check for equation 3. So equation 2, x plus y plus 4z is 4. Left hand side, right hand side. Left hand side is x plus y plus 4z. Right hand side 4. So here x is negative 20 plus negative 28 plus 4 times 13 minus 20 minus 28 plus 52. This will be minus 48 plus 52, and that will give us 4. 4 here, 4 on your left, 4 on your right. You eat some fruits. Oranges, pineapples, apples, guava, pears, and the rest of them. Equation 3, 2x plus 3z equal to negative 1. Left hand side, right hand side. Left hand side 2x plus 3z, right hand side negative 1. So this will be 2 times negative 20 plus 3 times 13, which is negative 40 plus 39, and that is negative 1. Negative 1 on your left, negative 1 on your right. You drink some water, not beer or Heineken or alcohol. You drink water, not soda, water. Alright folks, thank you for listening to this video session. We shall do the row reduction method next. We're going to do row reduction method next. Okay, thank you for listening. If you have any questions,